Okay, so continue this. So we are looking at conditional probability this time. And I said conditional, it's like having a non-replacement problem. So basically what that means is what happened before affects what happens next. Alright? And quite often people don't realise when it's a conditional or not. So for instance, I've got a question. You know the lottery, choosing your numbers for a ticket to win lots of money. Okay? If your numbers come up one week and you win the lottery, do you change your numbers for the next week or not?
Because they would be randomized again.
So you have a better chance if you change your numbers.
Yeah. There's no chance of the same numbers to come up again.
No, but it depends. If you stick with the same numbers, then eventually you will get it. You might. Well, no,
It's just how long that's a lot of money.
So it's gonna, but
It's just happened. So you think, here you go, here's the question. You think that because 6 numbers came up the week before, that they're not going to come up the week after. It can't happen. So you're telling me that because those numbers came up last week, the machine that does things completely randomly will choose not to pick those 6 balls again.
No, it could. But there's a very low chance of this.
Right, okay, that's not in question, the fact there's a very low chance.
Yeah, there is
But
some
does the fact that it came up last week have any effect at all on the fact it comes up next week or not? No. Right, here's the thing. That is not conditional probability, but people think it is. All that really matters is what's the chance of your 6 numbers coming up.
Isn't that like the thing he's like a vegan making machine that's like 1 times 2 times 3 times 4 times 5 times?
Exactly. Yeah. Did you do that? You remember that? Yeah.
It's like
Something like 6 factorial or
It's
something.
like taking like the code.
Yeah, it's how many possible combinations are there out of 49 numbers, and you pick 6 numbers out of those. It's something like 14.5 million.
Oh wait, there's something.
So your numbers coming up, you have a 1 in 14.5 million chance of winning. Now next week, you have a 1 in a 14.5 million chance of being right again.
Yeah.
With the same numbers. Or if you change your numbers. It doesn't matter. Alright, Sushi?
What about the Enigma machine, in which the code is always changing because of the wheels? So, of course, there's always a time when it will set back to normal, but it will affect whether the thing comes on the second time.
Well, that's the whole point, isn't it? So every time it
So if you have
changes,
an
it resets your probability. So until it changed, I think I'm not a big. I don't know an awful lot about it. I watched Imitation Game, and the idea I think it is that it sets a code, and you have 12 hours of using that code, and you have a very, very small chance of guessing the code. But as soon as it resets, you're back to the beginning again. So if you've got a 1 in 20 million chance of getting it right, you've got to get through all those 20 million combinations, but in 12 hours. And then it resets. And everything you've done up to that point gets wiped and forgotten. It's not useful anymore. Yeah?
But but this time, if you say the chance of you getting an H while typing an A 2 times is going to be different because it will change. So is that kind of conditional?
No, it's not conditional. It's just the fact that they change everything after 12 hours.
Yeah, but
It's like me saying, what's the chance of you dressing correctly in the morning if I set you a dress code for the morning and you turn up and I go, no, you're wrong. And you go back home and you change and I go, no, you're wrong, but you've got that bit right. So you go back and you do, and you keep, how often will it take you to turn up in the right thing? Yeah, and eventually you might turn up in completely the right outfit and I go, yes, well done. But tomorrow it all changes. So you wear the same thing again that you was right yesterday, and I go, no, sorry, all wrong. So you would have to keep going back. Now, if there was enough bits of uniform, right, so for you, shirt, tie, trousers, you'd only have to change like 5 things. So you go back maximum 5 times and you're sorted. But if there were 50 million different combinations of uniform, how would you get through all those combinations of uniform in one day? So you'd end up and you might get 2 of them right in the school day. And then next day, they're wrong. And you have to start from scratch again. And that's basically the idea.
Yes, but you type sentences in one day. So say you
but it doesn't affect what happened yesterday, does not affect the next day. That was the whole point.
Yes, but say that you type a double E. So the first E's letter, what is the chance of getting those double E's at the same coded letter?
But it depends what the code is. Because an E followed by another E might not be a H followed by a H in your code.
Exactly. So over there, is that like wrong replacement? Will that affect?
No, this coding, it's a bit different. You're not talking about. So the chance of you getting it right is a bit different. Anyway, you have to go and have a read up on it because I think we go and read on that situation if you like. Maybe it's a project for you to do when you're in your IB. But let's get back to a bit of a more simple case because everyone's wanting to get on. So this time, same kind of situation, but we've got 1 ball is taken from the bag at random. It is not replaced. Okay. A second ball is then taken from the bag. So basically, what we're saying is that what happened before affects what happens next time round. And the way is because of this. So first options, you could have a yellow or a red. What would the probability of getting a yellow ball be? Kim?
7 out of 12.
7 out of 12. Good. What's the probability of getting a red one? Amol?
5 out of 12.
5 out of 12. Okay. Then, I take a second ball. I could have a yellow and a red. I could have a yellow and a red here as well if I got a red. But, this is where the conditional probability thing comes up. So, Thomas, what is the chance of getting a yellow this time?
6 over 12.
No,
6
over
over
11.
6 over 11. Because
You took 1 out.
1 ball's gone, isn't it? So there's only 11. So in all of these, it's now over 11. Okay? So we can put that in to start with. The yellow becomes from 7 to 6 because we know that previously a yellow was taken. That's why the 6 has changed. But the red one was not taken. Therefore, what's the probability of getting a red now?
5 out of 11.
5 out of 11. So basically, we're saying that if a yellow was taken first, red is now more likely than it was before. And yellow is less likely than it was before. Do you all understand that?
Yeah.
Yeah? So what's the probability of getting a yellow if a red came first?
7.
Daniel?
7.
7 again, yeah. 7 out of 11. And a red would be, Leo? 4 out of 11. Okay? So you have to look at what happened before. And that's the conditional probability. It is, well, the probability is based on what happened before. There are conditions placed on it. Now we've got exactly the same situation we had before to work out the probabilities. So both balls are red. The probability would be, Ian?
50 multiply 5 over 12 by 4 over
Yeah, so it's this root here. So 5 over 12 multiplied by
4
4 over 11, which would be
20 over
132.
132,
5 over 7.
which would simplify. But we're not going to simplify because we might want to use. So this is 20 over 132. Both balls are the same colour, so we've already got red and red, and we need to add to that, Kemi. 7 over 12 times 6 over 11, which makes
42.
42 out of 132. And what do we do? So add them together. Good. 132 plus 20 out of 132, which makes over 132. Good. The balls are different colours. What would you do here? Sushi.
subtraction rule.
Okay, yeah,
So all we would cancel out is like a red, red, and yellow, yellow.
yeah. So we've already worked out the other version. So actually we can just do 1 minus
62.
62 over 132, which is
7.
70.
Yeah.
Sure?
Yeah.
70 over 132. Yeah? Got that? Everyone okay with that one, how we've used that?
Yeah.
Izzy, do you want to do the at least one ball is yellow?
Okay, so it would be like the one that we did before,
It would, yeah.
which would be you do yellow and yellow, yellow and red, and red and yellow.
Yeah. Or,
Or you do all of them. No.
no, not quite got it. Yadavi, help her out.
You do 1 minus 5 over 12 times 4 is 11.
So we've already got
Is that
20
red?
out of 132. So Izzy, you know, like you said, all the others, if we know that the red is the only one not to be considered, why don't we just do 1 minus 20 over 132, and then that gives us
112.
112.
112 over 132.
I get it.
Get it now?
Yeah.
So actually, all 4 of those questions have been answered by just doing those 2 and then the subtraction. Okay with that? Would anyone like to ask any question about what we did there? No? Yeah. Because
It's like
1 is,
152 over 150.
yeah, it's like 132 over 132. Yeah?
It's like a whole number.
Now the reason why I put 1 instead of 132 over 132 is because in your books you're going to see it written as 1 minus. And that's because this line plus this line plus this line plus this line, they all add up to 1. Well, in this case, 132 out of 132. But if we say 1, that applies to every situation. Okay? Make sense? Right. Any questions before I stop recording? No? Okay. Right, guys. So I'm recording again, just to let you know. So because you've been chatting a bit, on the end of this video now that we've videoed, and I'll put on YouTube, are those 2 questions. So, no, just this bit.
Super interesting.
So, for homework, I want you to have a go at both those questions. Okay? So it's there, as I'm talking now, it's there in front of you, so just click pause on the video.